You have many pieces of equipment in your lab drawer that can measure volume. These will vary in their ease of use as well as their accuracy and precision. In this lab, you'll use a beaker, graduated cylinder, micropipette, and burette to measure volumes. Some of these are designed to contain a specified volume, while others are designed to deliver a specified volume. The beaker and the graduated cylinder contain the volume identified by the graduations. The micropipette and the burette deliver the volume identified. For the graduated cylinder, you need to measure at the bottom of the meniscus. That is, when we put water into a glass container, the water is attracted to the glass, and so it curves up slightly at the sides of the container. And we call that curve the meniscus. Now we want to measure at the bottom of the meniscus for water. This is the center of the meniscus. If we had a different material in the graduated cylinder, such as mercury, mercury is not attracted to the glass, and so it will curve down at the edges closer to the glass. And that means if we're still measuring at the center of the meniscus, for mercury, we'd be measuring at the top of the meniscus. But again, for water, it's the bottom of the meniscus. Now we want to be careful when you have your graduated cylinder. You don't want to have it tilted, because that will, of course, change where on those graduation marks the level of the water appears to be. So you want to make sure that you have your graduated cylinder level. You also want to have your eye level with those graduation marks and the meniscus. Because if your eye is above the meniscus, you're going to be looking down through those graduation marks. If your eye is below, you're going to be looking up through those graduation marks. You want to be looking exactly level. But again, you don't want to be lifting the graduated cylinder up to your eye. You want to be moving your eye up or down to the level of the graduated cylinder. So leave the graduated cylinder on the benchtop and then crouch down if you need to look through so that you're seeing exactly level through the graduations on the side of the graduated cylinder and to that bottom of the meniscus. Measurement using beakers is identical to the measurement using graduated cylinders, except that the measurement using the beakers is going to be wildly inaccurate and often quite imprecise. After this lab, you should never ever measure a volume using a beaker. These marks on the outside are just for rough approximation purposes. Some beakers, in fact, even label the precision of those graduations. This beaker is labeled plus or minus 5%. A 5% error is really pretty bad. The next measurement tool is a micropipette. We have on the micropipette, we have a display. This one is currently set to 5 milliliters. This is a variable micropipette. Some micropipettes are fixed, where they only deliver a fixed volume. This one is variable between 1 and 5 milliliters. We have the plunger, and this green dial up at the top we can turn, and that will alter the volume displayed on the dial. Note that it's relatively easy to accidentally turn this dial a little bit and therefore change the volume that the pipette will deliver. Now with that plunger, we have two stops to the plunger. The first stop, as we push down, we get to some resistance, and then if we continue pushing, we can continue pushing the plunger down farther. Now that first stop is the volume set on the display. So if I have this set to 5 milliliters, if I push down to that first stop, I will have changed the position of the plunger by 5 milliliters. If I continue pushing past that, I will change the position of the plunger by more than 5 milliliters. And so you always need to be careful and be mindful whether you're going to that first stop or the second stop. So to dispense a liquid using the micropipette, first you want to set the dial to the desired volume. Confirm that you have the correct volume. In this case, I want to dispense 5 milliliters. Then you want to keep the micropipette vertical. You don't want to be tilting the micropipette at all. So keep it vertical for the entirety of the procedure. Also, while the tip is not in the liquid, you want to depress the plunger to the first stop. Then you want to lower the tip into the liquid to be dispensed, and then slowly release the plunger, ensuring that the tip remains below the liquid surface. Now, as you raise the plunger, it's going to be drawing liquid in. And so if the tip of the pipette is right at the top of the liquid surface, then you'll have a tendency to draw bubbles up with the liquid. You'd want to avoid doing that. So make sure that that tip is down into the liquid a little ways, and make sure that you're slowly releasing the plunger. If you just release the plunger all at once, you'll have a much greater chance of incorporating air bubbles into the liquid that you draw into the tip. If there are any air bubbles in the tip, then you need to push down the plunger all the way to the second stop, remove the pipette tip from the solution that you're pipetting, release all the way back up, and then start over from scratch. So push down to that first stop, then put the tip back into the liquid again, and then slowly release the pipette plunger. Now, after you've drawn the liquid up and confirmed that there are no air bubbles in there, you want to then take the tip and gently touch it to the inside edge of the beaker that you're dispensing out of to remove any droplets from the outside of the tip. Then you transfer the micropipette over to the container that you're dispensing into, push down slowly to that first stop, continue pushing to the second stop, and again, you want to remove any droplet on the outside edge of the beaker. Rather, the outside edge of the tip. So you want to touch the tip to the inside of the beaker that you're dispensing into. Then, gently release the plunger. Now, before you go to use the pipette again, you need to ask yourself, do I need to rinse that tip or replace the tip if you're disposing of the tip? If you're pipetting the same solution, then the tip may not be contaminated with anything else, in which case you can safely dispense that same solution again. However, if you're dispensing a different liquid, you need to rinse out that tip before you dispense using it again. The last measurement tool that we'll use is the burette. Now the burette has a very long tube, it's very narrow, and it has many graduation marks on it. The burette also has a valve at the bottom that we call the stopcock. Now for storage, that nut on the back of the stopcock is often loosened, and that allows the stopcock to spin freely, allowing air to dry the area around the stopcock. Now before you go to fill the burette, make sure that you have tightened that nut on that stopcock, holding the stopcock in place. There should be some resistance to moving the stopcock. It should not, however, be super difficult to move. You may have to play around a little bit with allowing the stopcock to move freely with some resistance, but not a massive amount of resistance. Now, with that valve, if the handles are parallel to the tube of the burette, then the valve is open. There's a hole in that valve, and that will allow liquid to drain through the valve into the tip. If, however, the handles of the valve are perpendicular, now the valve is closed. Now, there is a point in between there where the valve is partially open. And so you can use the positioning of that valve, whether it's perfectly perpendicular, perfectly parallel to the tube, or somewhere in between, to control the flow rate of liquid through the stopcock. Now, burettes are designed to allow us to deliver small quantities of liquid in many small portions. We'll often use a burette to perform a titration. Now, for this reason, we number the burette starting with 0 at the top, and it increases from there. So this burette has 0 at the top here, and it goes down to 50 milliliters. And this means that you need to be really careful because unlike with the graduated cylinder, as you have a volume of water, if it's slightly above the line in the graduated cylinder, that means the measurement of the volume is over that mark, over that volume. With the burette, with 0 at the top and larger numbers going down, that means that if the liquid level is above, away from the floor, a mark, that means it's below that volume. So you're increasing as you go down. It will take some practice to get used to this sort of measurement. Now, as you fill the burette, you do not need to fill it exactly to the 0 mark, because what we're using with the burette is we're looking at the difference in volume from a starting value to an ending value, or an earlier value to a later value. And so you don't need to get the volume to exactly 0. Just get it up here close to the 0 and record what its initial volume is. Later, you'll have dispensed some, and so you'll have some larger volume, and you can then subtract the starting volume. So if it starts with, say, 1.75 milliliters, already having been dispensed, and you then later go to 25, you'll need to subtract that 1.75 milliliters from the 25 milliliters to identify the volume that you've actually dispensed. Now also, when you fill the burette, it's a very narrow tube, and it has a tendency to get bubbles on the tube itself or bubbles in the tip. When you're filling, it can help to drain the liquid or to fill the liquid and have that liquid be falling down the inside wall of the burette rather than down the center falling through the air. If it falls through the air, you're much more likely to get air bubbles as it strikes the liquid at the bottom. So it may help to tilt the burette somewhat and have the liquid be running down the wall of the burette. In any case, if you have a bubble on the inside of the burette, it can help to hold the burette with one hand and with the other, take your finger and gently flick the burette wall, hoping to dislodge that bubble. Sometimes this works and sometimes it doesn't. Now, obviously, you don't want to be flicking the side of the burette too hard or you could break the burette. So if that happens, if you flick the side of the burette and you can't dislodge the bubble, in that case, what you'll need to do is open the stopcock, allow the liquid level to drain below the bubble, close the stopcock, and then gently fill with liquid again, hoping that you don't get any additional bubbles in the liquid. Also, as you're filling, you want to make sure that you don't have any bubbles in the tip. So once you put some liquid in there, open that stopcock valve, allow some liquid to drain through. That liquid that's drained through, you should throw away. You should not put it back into the top because it may be contaminated with whatever was in the burette previously. So allow some liquid to drain through, and again check to ensure that the entire tip is full of the solution that you have in the burette. Again, you may need to flick the tip of the burette a little bit to allow some liquid to drain through. You may also, if you have a very low amount of liquid in the burette, you may have to fill it a bit more to get enough pressure to push air out of the tip of the burette. Just like we saw with the micropipette, when you're dispensing liquids out of the burette, there will often be a small droplet stuck on the outside of the tip. Before you go to dispense anything, you again want to use a waste beaker and touch the inside edge of that waste beaker to the outside of the tip to remove that extra drop. Later, once you're actually dispensing into the reaction vessel that you have, you want to again touch that inside wall of the beaker to the burette to incorporate any volume that has passed through the stopcock and been delivered by the burette without actually having fallen off the tip of the burette. You then often would want to tilt the beaker to incorporate that droplet if it doesn't run down the side of the beaker into the liquid that you have in the beaker. Now in this lab, you'll need to convert the measured masses of water into volumes of water. You'll need to use the density of water to convert from mass to volume.
However, the density of water changes depending upon the temperature. And that's where this table comes in. Let's look at 15.3 degrees Celsius. In this table, the value is 999.0558 at 15.3 degrees Celsius. Now, to save space, we've left those first three digits off of every column except the first column. So you'll find the temperature that you actually measure, find the density at that temperature, and then if you look up at the top of this table, it says the density of water with units of kilograms per cubic meter. Now, you did not measure your mass in kilograms, you measured in grams. So you'll need to convert from grams to kilograms or vice versa. And we don't want the volume in cubic meters, we want it in milliliters. So you'll need to convert from cubic meters to milliliters. And an important conversion to remember here is that the liter, 1 liter, is defined as 1 cubic decimeter. The rest of the conversions involve changing the prefix on an SI unit.
So here we have some data. We have some trials 1 through 5. We have masses of water in grams. And if we want to calculate the average standard deviation and percent relative standard deviation for these, we'll first come down into a cell that we want to place the average in, and we'll type equals average, open parentheses, and the easiest way of doing it is then to click and drag, selecting the cells that we have the data in, close parentheses, and press enter. That will then give us the average mass of water for those 5 data points. Next, we'll do in the cell for standard deviation, we'll type equals STD EV, and in this case we want the dot S. We don't want the dot P. That would be if we were calculating the standard deviation of a population. In chemistry, we're pretty much never going to be having measurements of the entire population of something, so we are almost always going to use the dot S formula. So open parentheses, again, highlight the cells that we want to calculate the standard deviation for, close parentheses, and enter. For the percent relative standard deviation, we can use our standard deviation and average. So we'll type equals, select the cell that the standard deviation is in, type a slash to divide by the average, then select the average. And now this is going to give us a fraction. So this would give us the relative standard deviation, not the percent relative standard deviation. So at this point, we just need to multiply by 100% and hit enter.